In this video, we look at the energy stored in a capacitor. As I mentioned earlier, a capacitor is basically an energy storage device using the electric field. Now, one of the things that we know, of course, is that there is this connection between the change in the energy stored and the charge times the change in electrical potential. This is where the definition of electrical potential was. However, in the case of a capacitor, you don't have it where the voltage is maintained at a constant rate and you move a single piece of charge. In fact, as you move the charge between the plates, you change the voltage between the plates. Well, we can still find the energy from the area under the curve, and in this case we know that there is a straight line dependence between the voltage and the charge. Voltage is equal to Q over C. So the slope of this line is 1 over C. And when you're talking about in these formulas, the Q that we're talking about is the final Q, and the voltage in the formulas for energy is the final V. And so as you added charge, the voltage was changed, and you're looking for the area under this curve right here. So this is the energy stored is area. Now, that's a triangle, which is very simple to find the area for. So the area is equal to 1/2 Q times V. But we know that V is Q over C, and of course Q is CV. So we can rewrite this equation in two usually more useful forms, in which we say that the energy stored is Q squared over 2C, where we have substituted in for V, or 1/2 CV squared, which is more commonly because usually we use a battery or something to set the voltage. So these are really, it's just the area under the curve, but you can rewrite it using the definition of capacitance in a couple of different ways, and I would say that the last one here is probably usually the more useful of the three. Now, how much energy is stored in a 100 microfarad capacitor at 100 volts? Well, U is 1/2 times 100 volts squared times 100 microfarads. So we're looking at 1 times 10 to the 6th over 2 times 10 to the minus 6 joules. So this is 0.5 joules, assuming I've done the mathematical calculation right. So a 100 microfarad capacitor with 100 volts can have half a joule of energy stored in it. Alright, that finishes this video.